So first of all, thank you for coming this late hours of the conference. I know you're potentially tired. My name is Luka, and today in this couple 60 minutes we are going to talk about blockchain and just introductory lesson of to understand building blocks and what goes into a blockchain. So the goal of this presentation and the workshop is for you to understand crucial parts, and if you decide to build something on top of it or just to invest, to have a better decisions for you. So it's not going to be a technical talk. I'm not going to talk about code and stuff like that. We are not going to do that because, I don't know, can you raise your hand if you are an engineer here? Cool. So we have a couple of engineers, but most of them are not, so we are not going to talk about code today. Cool. So the talk is split into 4 different sections. We are going to start by introducing what is the transition between Web 2 and Web 3. So just to give you a context of what is the main difference, what is the crucial difference. After that, we are going to talk about what is actually blockchain and building blocks of that. And then we are going to talk about dApps. Potentially you heard about them, they're everywhere these days. And we're just going to demystify what is actually dApp. It's not that scary actually. And after that, we are going to talk about some use cases such as NFTs and DeFi and all of those buzzwords that you are going to hear in the blogs and news. And I know it's not that great time for this talk because we had so much a backlash happening in a couple of days with FTX and stuff that happened. I don't know if you followed, but we had so many problems in the crypto space. Okay, cool. So, okay. So basically, what we have now, the traditional apps that we are all familiar with, for example, you're using Facebook or Google or whatever, it's built on an architecture called server client. And what that means is basically you have some device that you are using. Like all of us have phones, laptops, and any device that you imagine, even these days TVs. And when you want to reach some of those services, that data or those services is located to some server. That server might be in Serbia, it might be in US, it really depends on the app that you're going to use. And for example, when you Google something, you write, okay, what is happening with, I don't know, cryptocurrencies these days. You're going to send that request is going to be sent to the US servers where the Google stores their data. They're potentially finding the answer that you are satisfied with, and you're going to see that answer in your browser. So that's what's happening these days. And that's kind of a Web 2 version of it, and we are all familiar with that. And basically, we are using that for more than 20 years right now. And that is many of people who are trying to build something on Web 3. And why is the Web 3 really popular in millennials and the new generations is because people don't want to share the data. They are really scared about their privacy of the data. They are scared about things that Google, for example, can use with your data. And by the way, if you have any questions, then we can go into discussions of ethical stuff of those technologies, because I'm doing that as well. So just stop me, raise a hand and ask a question so you don't have to wait any cues from my end. So many of the people who are working in the Web 2 and trying to change something to the Web 3, we are going to discuss what are those problems and benefits of Web 3, trying to leverage the power of not one of these servers, but many of them. And that's what Web 3 basically represents. So let's give that server to any of us. For example, all of us here can be Google for itself. So what's happening, you have some piece of code running on a server, you're going to send a request, I just talked about that, and that's basically what's this architecture. And in the Web 3 era, we have a new term called decentralized. It's not basically new, but they're using that to describe what's happening with Web3 these days. And architecture looks something like this. So you have many of the computers. All of us have here, for example, an iPhone or whatever, Android phone. And that Android phone can be that server for itself. So what's happening there is, okay, let's say we have some information that I want to reach. I want to find out what is the picture of a cat climbing a tree. These days, you would basically go to Google Images, probably some other services as well, Google that description, and then Google will find out that information. But what's happening in the background, when I send that information when I send that query to the server, Google will already have one point about myself and saying, okay, so Luka loves cats and wants to see pictures of cats. And based on those requests that are not that scary for us, we are just wanting to see a simple image of a cat, you're going to be flooded with ads about cats tomorrow, maybe 5 minutes after that query. And in this architecture, all of us here act as a simple server. So imagine that I want to say, hey, guys, do you have any picture of a cat climbing a tree or whatever I said before? I want to ask you, and then you're going to browse your galleries and show me the picture. That's basically what it does. So all of us act here as a kind of individual node in that service where, for example, myself, I don't have that image, but some of you or all of you might have that. And in this sense, the app that I talked about is distributed on your phone, and any node in the network. So basically, that is the first difference between Web 2 and Web 3, what we want to reach. So we are trying to remove that one single point of failure from the big corporations to basically put it into public use cases, and everybody will have the same access and the same level of transparency in the app system. So basically, that's the main difference. Is that clear so far? Cool. Do you have any questions? Okay.
I have one.
Yeah.
So do they each of those pieces hold a part of the information or the information as a whole?
It really depends on how you build an app, the system that you want. It can be like simple like pieces of information. Let's say we want to I don't know, store the whole sequence of Shakespeare, like, books or whatever. So you can have one story. I have the other one. And when somebody asks for the whole set of those, it will reach to your computer first, then mine, and so on. And we are going to talk about later when we talk about NFTs, like how that happens. But basically, the idea is sometimes in the blockchain, in particular, like cryptocurrencies, you all heard probably about Bitcoin and Ethereum and stuff like that. Every node will have the same copy. Every node will have the same copy in their system. Cool. So some of the benefits that people younger, and you will notice that everybody who is working in Web3 are so young, they don't know what they're talking about, but they just want to build stuff, you know. And obviously, because everybody is concerned about privacy these days, everybody is concerned about like, security and stuff. They don't know what they're talking, but they are concerned. So the first is decentralized. Like we talked about, hey, we have a Google. Like when you search something, Google will have that information about you. Which for some of us, like if a product that you're using is free, you are the product. And for some of the products, I'm okay with that. Like I'm using Google for ease to reach some information that we didn't have like a couple of years ago. And when I search that information, Google is basically earning money of me. And I know that. I hope you know that as well. For Facebook as well, Instagram, and all the social media, wherever you use, if it's a free, you're the product because you're generating data. You're generating tremendous amount of data, like even petabytes per month. And what's happening these days, because of the corporations and how they're built, they are using each other to leverage your information. So for example, if you search for cats on Google that I mentioned, Instagram will have that information as well. It's not the same company, but they're sharing information. So when you go to Instagram and browse your images, there's really high likelihood that some of like toys for cats will jump up as an ad. Hey, we have a new toy. So that's normal, like normal. We can discuss that, but that's what's happening. And in these systems, in the Web3, you don't have that. So because of that, like the first is decentralized. We are not leveraging the same, like one single point of control of the whole information. So when you have a single server, every single information is in their possession. And in the new one, in the previous slide, I don't know why is this, okay? In this, everybody have the same information, so nobody is really the owner, except you. Okay, then we have transparency. So everybody knows what's happening. Everybody. Like, for example, we are going to talk about code and stuff like that. Right now, like we have a couple of engineers here. When you are engineer, you're writing code that's IP for the company or yourself, depending on how you write the code. If you share the code for somebody else, you're basically losing the advantage in today's world. So you can't see the code that runs Google or Facebook or whatever company. In the Web3, however, everybody sees the code. And that will provide some benefits, but disadvantages as well. We're going to talk about that as well. Speed. So like speed is more related on transactions, because right now we are waiting for banks to run our transactions when we send, for example, money to some account. If it's a wire transfer, it can be a couple of days. In the Web3, when you use cryptocurrencies, it's a couple of minutes. So if you have more power in the systems, you will have really big speed. Then you have trustless system. So what's happening here, you're basically saying, okay, if I want to store money, like everybody potentially use m-banking right now in Serbia, and we are just giving trust to our banks that they are not going to run away with our money. Okay, well, that happened in 2008 and potentially before and stuff like that. I'm not that old to understand what happened before. But basically, we are just giving trust and saying, okay, for that trust, I want you to store my money, and I want whenever I want to send, pay something, I want immediately to have access to that money. But yeah, sometimes it's not that the case, So when you have the single point of failure in the banks, like the server, when you have a Google, it's just like simple query of information in the banks, that's your money. So yeah, for me, it's not that comfortable, In this system, you are not trusting anyone. So basically, when you send a transaction, we're going to talk about how that transaction happens in the network. You are basically saying, okay, cool, I will put that transaction, everybody sees what's happening. I have address, you have address, I'm sending you money, everybody sees that I sent her money, and that's it. If I have enough resources to send her money, that's going to be executed. If not, well, obviously too bad. And I wrote speed twice. It was important for me, potentially, yeah. Cool. Okay, so this was just a brief introduction of what's like difference between, just to build you like understanding of what's happening in the background on a really high level. Let's dig deeper. So blockchain is basically a chain of nodes that's connected somehow between each other. And people are talking and building complexity on top of blockchain so much, but it's really simple. So we are going to understand what's actually blockchain in 5 minutes, 10 minutes. So each block, you can imagine that is just this yellow-orange square. That's it. So one block contains some information, and how it's stored in the computer doesn't really matter. It's just information that is stored that matters to us today. So you have block number 1. You can name it whatever. You have some data. We'll explore the data in a bit. You have some previous ID, and block ID 1. So this block ID has ID 1. This previous ID is a bit concerning, what's happening there. So let's add another block. So you can see that block 2 just increased the number of ID. Like you can see the block ID is number 2 right now, and previous block is 1. Okay. So if I add block 3, you can see the pattern. And we can connect it. So the blockchain is basically this. You have some blocks that's happening in a sequence, really important, in a sequence, so you can't change the sequence. When the sequence happens, that's it. Forever, that's the storage. Each block is connected to previous one with their ID. So for example here, let me move it there. This block has ID of 1. And previous block basically says, okay, what is the ID of block that happened before me? In this case, it's 1. So that's why I have 1 here. And in this case, previous block of block 3 is 2, because it's pointing to the previous one, and so on. So if you have a million blocks, well, that's the same pattern. It's basically just increasing the numbers that's happening there in the sequence. That's a blockchain. Thank you. I'm joking. Cool. So now I just changed these IDs to something more complex. So instead of IDs, I introduced a new keyword called hash. If you're not from IT, that may scare you. And you should be scared. I know, you don't. But basically, the hash means just a unique ID that's going to be calculated with some formula. We're going to explore how right now. But instead of having 1, 2, and 3, we're going to have some random numbers. For you, you can be a random number. It doesn't matter. It means just it needs to be unique. So the same hash shouldn't be repeated twice. And it can't. So what's happening there, you have some data that we put through that algorithm. And that algorithm will spill out some sequence of characters, numbers, and stuff like that. And every time you put that data, it will spill out the same information, the same hash. So for hashing, we'll explore what's happening now. You're one-way encoding. Why is that? When you put the data, any data, it can be a simple number, it can be the whole transactions. Like for example, I'm sending you money. When I put that through the hashing algorithm, we are going to receive that sequence of numbers, okay? Whenever, like tomorrow, when I put the same information, I'm going to receive the same hash, the same sequence, okay? But it shouldn't be reversed. So when I put the sequence, I shouldn't be able to get our transaction because that's privacy. Deterministic, when I just explained, so whenever I put the same information, I'm going to receive the same sequence of numbers. That's it. Fast computation, basically, it needs to happen really fast, like in milliseconds. And the avalanche effect is basically this. When I change one character, when I say, okay, my name, it's going to spill out something, some sequence of numbers. When I change from Luka to L-U-C-A instead of L-U-K-A, every single number will be changed, and that's called avalanche effect. So instead of changing like just, let's say, 10 at the end, characters, it will change everything. And to better understand what's happening here, you can scan this QR code with your phones, and you can play with this tool. Did you manage to get it? Do you have any questions so far? Should I go slower, faster than this? Okay. Cool. Okay. If you want to scan this QR code, just let me know. I'll circle back. Okay, so let's go and talk about immutable ledger. And this is a term that is potentially going to be repeated multiple times, not in today's session, just once. Everywhere you go, the blockchain is called, other words, immutable ledger. Immutable basically says, okay, it can be changed. So what's happened in the past, that's in the past. If I try to change it, it will break. We'll discuss how it goes break, but basically that's it. And ledger, well, set information, that's it, storage. So let's go and explore some case of buying a house. So what's happening today, you have some money, you want to buy a house, you go to a realtor, for example, and say, okay, hey, I have this money, I want to buy your apartment or whatever. You sign a contract. You go to a bank and say, hey, I want to buy, or I want to borrow some money if you need more money to buy that property. And that's going to be in that order, potentially, here and there. But in Serbia, it's not that. Somebody will sell the same house twice, and stuff like that. That happened, So, in traditional way, you can't change what seller wrote. Seller can go to me and say, hey, I really like you as a buyer. I want to sell you the house. I say, yeah, I bought the house. I sign a contract, and tomorrow, hey, this guy offered more money. I changed my decision, I'm going to switch to this buyer. That happened. In the US, it's happening all the time. In the blockchain, however, let's see how we can use blockchain to change this way of purchasing a house. So, and by the way, just information, Slovenia is already using this system for buying all the properties in their system, and for government stuff like relatively all things transaction related are happening on the chain right now. So what's happening here, you have some information, you know that you have blocks, and each of the blocks we store the contract and say, hey, I bought this house, Luka signed the contract for this amount of money, and we add it to the chain. Somewhere in the past, let's say it happened a couple of days ago. After that, somebody else bought a house, and somebody else, everybody, the whole country is buying a house. For each of the houses bought or sold, we have this one single block. But my seller wants to change that and say, okay, I don't like Luka anymore, I will sell it to Marco. And he goes and changes the contract, or sells the same house twice. The whole chain breaks. Everything after that transaction will not be valid anymore. And why is that? Well, we talked about the hashing algorithm, that basically you put some information to it, it will spill out the same sequence of information which is used as a previous hash. And if the previous hash is not the same, well, everything after that breaks. So that's not even possible right now when we have the transaction on the chain. Does it make sense? So that's basically one of the use cases what we saw happening on chain, and not not only cryptocurrencies, but basically that's something that you can use today's technology to build your company and allow them to have the unique transactions that will never occur twice. And one information, one company from Dubai, when the COVID started, the whole outbreak started, they wanted to provide the proof of tests that where those tests were produced. So every single piece of that test had the QR code that can be linked to the factory and the line in the factory where that piece of that test was produced. So it had about 10 individual pieces. When put together, the whole had the same unique QR code, and every single piece of that tech was stored on the chain. So it can be changed, and it will always stay forever there. So whenever you have a test, you can scan the QR code and circle back and see if that was the right test that you bought or the falsified one. So that's basically, and they built $1 billion company of that. Back to your question. What's happening? Do you have the same information to all the nodes in the network, or just pieces of information? So in the blockchain, one of the things that we talked about so far, we have that chain that can be changed. But okay, so if I'm the only one with that chain, and I'm only one who is controlling that information, I can change that past and change all the future ones as well. And if I'm the only one who is controlling, who is, for example, buying or storing that transaction to the chain, nobody can stop me from changing that. And we basically get the same infrastructure that we have right now with all Web2 companies. So the power here comes with introducing more computers in the system, where every single computer have the same copy of the information in their storage. So when I buy a house, not only that I'm going to store that information to the chain, but every single piece, every single computer in the network will have that information as well. And it will be added to all of the nodes, okay? So you have 6 nodes here, 6 computers. When I say node, it's basically device. It can be a computer, it can be a phone, tablet, whatever you have at home. Or more powerful computers for mining, that's another story. But yeah, so every single computer node will have the same information, the same copy of that chain. In this case, we have only 3 nodes, just for demonstration. It will be 40 terabytes of information these days, just to store one single blockchain. So now that we understood what's happening, how that is going to be distributed, and whenever we make some transaction, it's going to be distributed to all of the nodes. But how? Who is going to make the decision to add that transaction to the node? We can't simply say, okay, I'm going to buy a house, and without checking whether or not I have enough money, for example, or I'm going to send you money and not having enough Ethereum, for example, to send you. Somebody needs to check that information for validity and to prove to all of us here that that transaction was valid. So that's happening with mining. So miners are basically nodes, the computers in the system, that takes those transactions that are currently happening and say, okay, let me take this transaction and validate it. What it means is basically, okay, let me check if Luke has enough resources in his account before sending to her Ethereum, for example, or if I want to buy a house, if a seller has that property in his possession, if Luca has enough resources and so on. So miners are going to validate that thing, okay? And why? Well, miners get money for that. So if you are a miner, you're going to prove the transaction was real and you're going to get paid. So there is no such thing as a free lunch. So in these systems, if you want to participate as a miner, you're going to spend energy, obviously, as electricity. But as users, if you want to send transactions, for example, if I want to pay somebody $100 in whatever cryptocurrency, I need to pay a fee. And that fee doesn't go to bank. It goes to miner, who is going to say, okay, cool, Luca actually had $100, and it sent that $100 to the correct address. So what's happening here, I don't know what's happening with computer, but okay. So we have some block, and each of the blocks have you know that some data that we wrote in the middle, we have the transaction. So you can have multiple transactions in the same block. We're going to talk about selecting those transactions. It's really simple, actually. But you have some transactions that miner said, okay, I'm going to select those, and I'm going to put it in the block. And you're going to, so what's happening now? You're going to say to put this information, block 2, all the transactions and previous hash to that hashing algorithm that I sent you to scan. So all of that information is put together to get this number. And what's happening? Well, it's not that fun. So if all of us can do the same thing, we're going to have the same hash. So how to decide which miner is going to get money? Well, for that, we're going to introduce a new term called nonce. The nonce is a simple number. That's it. I just put some random numbers here. Don't mind this number. But basically what's happening, because we don't have the control, I can't change the block name. So it's static. Like that's happening. Like if it's a second block in the node, in the blockchain, that's a block 2. It's unchangeable by me as a miner. Previous hash, we can't change that. It already happened. That's it. Transactions, we can choose which transactions we want to put here, but they already happened. They like Luka sent her money, or somebody bought a house, or whatever. Like we can't imagine those. Like they are happening. They are not generating, but miners, they just can choose which they want to put here. So, okay, but we have all these static things. We need some control over that. That's why we introduce nonce. The nonce, as I said, is simple number. And what's happening in a miner, when miner gets all those transactions, they put all these things through hashing algorithm and put 1 as a nonce and put it there. They got some hash and they say, cool, it does not work. Let's put 2. And then 3, 4, 5, 6, and they're increasing nonce by 1 every single time and putting through the same hashing algorithm that you just saw. And they are trying to get some block hash that works for that system. Like blockchain has its own parameters, how those block hashes should look like and stuff like that. But miners basically try to match the system they are mining for. Like is it a blockchain, is it Ethereum, Polygon, or whatever. And that's it. That's basically how mining works. They get some transactions, they can choose to change only one number, which is nonce, and they put it through the hashing algorithm. If you have more power, if you have GPUs, if I only have my laptop, for example, and you have like a GPU of, I don't know, 3090 or 14 gigs of RAM, you are going to change and check those nonces faster than me. And who is the fastest? They're going to get a reward. That's basically how it works. You potentially heard, or if not, when you finish this session and go home and read about it, that's proof of work. That's basically how it works. So proof of work, if you heard anywhere about for the blockchain, that's what it is. So some miners trying to check what is nonce is and hashing all the things and trying to get the block hash that works. That's it. Simple. And people are making fun of that, yeah. So basically, that's it. When they find the block hash, they're going to be added. But this is a miner, traditional miner swimming around transactions in their house. It's a just metaphor, not really. But basically what's happening, you have a guy or a computer, it's a computer, not a person. You have all transactions. Let's say I send you money. You try to withdraw money to your bank account. Somebody from here sends somebody else money and stuff like that. We have thousands of transactions happening in the same time. But miner has only, like, let's say 10 that can put at the same time. So they need to choose which transactions they want to put in the block. They have thousands. They can only choose 10. How? Well, we as a transaction leader, like who is going to initiate the transaction, is going to choose how much money they're going to give to the miner. If you want your transactions to happen faster, you're going to say, I'm going to give you $100. If somebody who is cheating the system, that happened a couple of weeks ago, they will give you $10,000 to mine the transaction. And miners will say, yeah, I'm going to get the $10,000. They don't really care what's happening in transactions, they just want money. So miners will swim around transactions, and basically it's called mempool. Because of that, I choose that picture. Mempool is nothing but the place where all the transactions that needs to happen are stored. That's it. Like just big table of transactions that are in the process of happening, and for each transaction you have what's happening. Like Luka sent money to this address, and Luka choose to give you $10,000 for that transaction to happen. Okay, that's it. Miner will go and choose 10 top transactions that needs to happen. The simple heuristic is what 10 will give you the most money for. So they're going to choose that, and that's it. If you're poor and you don't have enough money, well, your transaction is never going to happen. So yeah, that's the system, how it works today. So now you have, like I just demonstrated here, you choose like, let's say here I just choose top 3 transactions. I'm going to put that in the block and trying to choose that nonce. I didn't have it here. I'm trying to choose that nonce that's going to generate this hash, and that's it. Basically, that's what's happening in the mining process. And right now, that's happening in the same one computer at a time. So I have, let's say, GPU 3090. At home, I'm trying to choose those top 10 transactions that are going to leverage most money for me. I'm going to mine them and say, cool, I found the hash. It took me only a day, but I found it. And what's happening, I have a new block. My chain is different from all of you. So I choose 10 transactions, I added it, and that's it. Right now, I need to send that information to all of the nodes in the system. I just ping them and say, hey, I found the hash. They are going to take that information, check on their end, that's happening in milliseconds, and say, cool, you've done the work, proof of work, and that's it. And the longest chain rule works. Basically what's happening, I mine the new transaction, I mine the new block, everybody in the system, all 5 computers, will get that copy. And right now, all of us will have the same information that I, at my computer, mined those 10 transactions. Those 10 transactions does not exist in the mempool, so no other miner will choose them because they're already mined and added to the chain. But what's happening if 2 of us have the same GPU? Well, do you know? Do you have an idea? Sorry?
4?
Yeah, it can be. Yeah. It's in a new Ethereum system like that. Yeah. So what's happening is we're going to stop everything. And my computer will have those 4 transactions happening. That Marco, for example, will have 4 transactions in their system. But no other will take any of those copies because we don't know which one to choose. They are the same length. So we are going to wait for 1 more transaction to be added to block. And all of the things that I worked, well, no fun. I didn't get anything. They will be replaced with a new chain that is longest one. So basically the system who is the most powerful will get the leverage and earn money. So if I spent the energy, I spent the electricity to mine this 4th block here, but no luck, I didn't earn anything from that. So that's how it's happening now. And obviously, China dominates here because they have like 2 clusters that are mining like nobody can be faster than them. They have basically like 3 buildings this size that are just mining Bitcoin right now. So yeah, nobody can over-dominate them. So what's happening, like simple users who have only 1 GPU and stuff like that, they will take the lowest earning transactions, like with the least amount of money, because Chinese people will never take them. They want, obviously, the most expensive ones. And we are going to have those simple transactions mined, but really slowly. So we are going to earn money, but so much less than them. So that's what's happening now. Cool. And if you want to check, like this is another thing that you can check and play with. It's basically the whole blockchain and what's happening when you choose to change some information that happened in the past and how it overrules everything that I just showed.
We have a question on
Yeah.
this. Okay. In the beginning you said that this is kind of a decentralized ledger and trustless system.
Yep.
And you made an example, good point about banks, especially here. But isn't this just moving the responsibility or the trust to someone you don't know? For example, banks can be regulated and are regulated, and even if they just take the money and go away, you have some kind of insurance. But now, as you pointed out here, the one who can generate more blocks takes the monopoly on the decisions in the system. So now instead of someone you know, you put trust in someone you don't know. And who is regulating them? For example, if China now has, I know everyone will say, well, yeah, it's proof of work or proof of stake or some other investment. But for example, China has a lot of resources, and they probably won't try to cheat on you, but they might try to cheat on, I don't know, Germany or USA financial system.
That happens.
They actually have the resources.
Yep.
So why is this system better than a regulated industry where you know the players and those players need to put some other insurances in them?
I wouldn't say it's better. So that's the first thing. The second thing is I don't know really the bank. Like I trust them, kind of. I trust them that they are not going to screw the money because there is so much like overhead in their end because of the whole regulative stuff like that. They are basically like the government is kind of a controlling banks, you know, like they need to print money, for example. They can't do it on their own. So kind of a government is there that we need to trust if we are trying to trust the bank. But like the system like this, you're completely right. You need to like move that trust to some person that you really don't know. And that's something that I'm not really fine with, you know. So one thing is like, okay, so bank has some incentives to like store the money with them. They're going to reinvest that money to somebody who is creditor or something like that. In this system, you have a direct like incentive for the miner to mine it because they are going to get the money for taking your transaction, for example. So it's kind of mutual benefit, and that's why it's kind of a less friction in the sense of the trust. But when you say the trustless system, it means more on the end of storing the money. In a sense, okay, when you store the money with the bank, you're trusting that bank will not fail and will not go bankrupt, for example. If they go bankrupt, there is some like, I don't know, $50,000 in Serbia, something like that. But when this happens, if one of those computers fail, if the whole China fails, for example, and they are not able to mine anymore, that's fine. Somebody from Russia, from Germany, from USA will have the same information, and you can take the money with you into your bank account finally. So in that sense, like there is no one single point of failure. That's why it's kind of a trustless.
Yeah, but on the other hand, if they fail, okay, someone else will take the work. But if they, for example, want to cheat, they have the power to write new history whenever they want.
That's
if they have the monopoly.
So okay,
computational power.
that's a great point. there is something that's called 51 attack in the blockchain, where if you have enough power to overrule every single node, like all 51% of the nodes in a system, you can overrule the whole history and say, okay, I have the right chain, and all of those chains that you have in your computers are not valid anymore, take my chain. So for that to happen, like for example, I have my 3090 GPU, you have your 3070, then somebody else has iPhone or Android, and trying to mine from those small devices as well. That's today possible. So all together, if we collectively have less power than one single node in China, that's the point where China can overrule and say, hey, I have a right chain, you don't have one. And we need to comply with that because they have more computing power over us. For that, China government actually destroyed one of those mining pools. They are not available for blockchain anymore, not blockchain, Bitcoin anymore. I think they are still mining Ethereum. We need to check that, but I'm pretty sure that's the case. But when they were active, the two of those mining pools have 55% of the power of all the nodes in the network. So we say that Bitcoin is decentralized, but it's really not. It was not, because the China has had 55% of the power. But yeah.
The idea is fairly good.
Yeah.
It sounds like utopia, but when you think about it, because of the uneven distribution of money, you will gradually converge to a situation where a very small number of people have control over the half of the nodes or the power of the nodes. And even though the Bitcoin and Ethereum and many other blockchain platforms are still growing, I do not see in the end a vision how will we overcome such limitation.
Proof of stake. Proof of stake changes that. Sorry guys, I'm using another term, proof of stake. So basically it's really simple. I mentioned proof of work, where you as a miner change that one number and trying to get the same hash. Proof of stake is basically if you want to get to be a miner, you're saying, here is my money. You're always giving 15 Ethereum. So it's about, right now, $30,000-$40,000, something like that. So you're basically giving your money and saying, hey, this is my stake. If I make a mistake or I validate some transaction that is not correct, take my money. So you're basically saying, here is my $40,000. If I validate some transactions, so for example, I send you 100 Ethereum. I have only one. And somebody validates that, and amazing. Luka sent 100 Ethereum. And other in the node say, okay, well, that's not correct. Luka does not have 100 Ethereum. You're out. And they're basically going to take your $40,000, and that's it. And right now, with the method that I explained, basically who has more power will go through those nuances faster and check what is the correct answer to that equation. In this proof of stake, we don't really care. Like if you have an iPhone, if you have a super cluster computer, the rule applies the same. We are going to wait you patiently for to validate transaction. Does it take 1 day or 1 second? It doesn't really matter. It's for you to validate that particular transaction, randomly chosen. So if all of us have here the power to validate some transaction, I'm just randomly going to pick blindly the point of finger and say, hey, you're going to be one who is going to validate my transaction.
But it's not so randomly. Is it according to how much I have already at stake?
It's always the same. 15 Ethereum. You can't leverage more than that. Yeah. You can lose more than that actually, but you can't leverage more. Yeah. The first version was basically that, how much you put. That's going to be weighted on who is going to make a decision, but whales will be the most powerful. So somebody will give $1 million and everybody will dominate the whole network. So the same thing would have applied. but Ethereum is now on the proof of stake, so it is more secure in a sense and faster in the decision making. But I would not suggest investing right now. The worst time to invest. Okay. Cool. So, have you heard about dApps before I jump to that? Okay. Do you know what apps are? Well, we have applications, obviously. dApps is basically a fancy term for decentralized application. That's it. So basically, imagine that you have an app that is copied into all of the computers in the network. That's a dApp. And why is that powerful? Well, don't watch the code right now. You don't have even to understand it. So basically what's happening is you have somebody who is going to write an application and it's going to be deployed to some server. So that server will contain that application. We're going to interact with that and so on. You don't see one thing, that's cost. So we need to pay for that server to execute our code. Like when I want to search something on Google, Google needs actually to run that server. So there is electricity cost, there is data storage cost, there is management cost, people, whatever. Like there's so much overhead just for me as a user to search something on Google and get the result back. We don't have to be kind with Google. Google is earning a lot of money to pay for that, but basically that's something that's happening right now. In the dApps situation, you are leveraging that power of all nodes that we just mentioned to execute our transactions. And what's happening here? You have some simple app. This is just a code. As I said, you don't have to understand it at all. It returns one number. That's it. Just one number, any number. And you're going to write the code, if you're a programmer here, the same way that you would write any other application. But instead of, okay, yeah, you can, if you're a programmer, you can use this, but I will put it at the end. Come on, okay. So we have some application, some code that's going to be written by your developers, and that code will be packaged and put as a transaction. So miner right now can say, okay, I have a transaction when somebody sent somebody money in that mempool swimming, you know, around and choosing what transaction to choose. And some of those transactions will be, hey, this developer have a code to deploy. That's the same. We still need to pay the miner to choose our transaction and say, hey, I have this code, but I'm going to give you $100 to put it on the chain. Okay? And when you look at the block, basically it will be transaction 1, transaction 2, transaction 3, no difference. Like there will still be the 10 transactions that miner can choose. They are still going to choose them by how much money they're going to earn. So nothing changes. But instead of having information that somebody sent somebody money or withdrawal to the bank account, that somebody wrote a code. That's the only difference. Like the source of that transaction will be different, but the whole process that we just talked about is the same. So for developers, that's basically the process. We still have that. And right now, that code is distributed everywhere. The piece of code is in all computers in the world. And when somebody wants to interact with our application, they can interact with the blockchain wherever that is. And who is the closest to us, obviously, will have the fastest response time. And your user will be happy. So how that works? In traditional way, you have some code, some website, that's an API, for example, and you would call the function called getNumber. And that getNumber will just return the number to user. It's not really fine application, but it's just an example. So you will have that. And instead of having that, you will have a hash. We talked about hashes and how we ended up with this number. Just a random hash. Instead of that www dot whatever, you have this. Okay? And because we talked about every hash is unique, so every of your applications will be unique as well. This address will be unique. And this will point to your application only and no other. Then it will create transactions by calling a function. So this is a bit convoluted. Let me explain. So when a user from your front end called getNumber, click a button, like you go to a website, simple, click a button, it will call this monstrosity of the address, and in the backend you don't see that function is called in the code. And that basically creates the transaction. We need to pay for that as a user, and miner will see, oh, hey, we have a new transaction. Somebody will pay me $3 to get somebody to get a number. And that's basically how it works. So when somebody clicks a button, we create a transaction, we need to pay, and the miner will work the same process and return the number to us. Transaction is added to that pool, and obviously miner adds that to the chain. And we get some output. That's it. Does that make sense? Is something unclear? Do you want to dig deeper into any of those parts? Yeah?
Just a short question.
Yeah.
So we had that store number and retrieve number,
yeah,
something like that, but both of these endpoints will effectively, for each call, add a new transaction
yeah,
to the chain, and when it gets verified
yeah,
and added to the blockchain, we will get the results and have to pay for that call.
Yeah, exactly. So instead of having like get number, set number, like all those are pretty abstract and not really useful, to be honest, you can have a function called buy a house. And that buy a house will take your address, take the contract that you signed, take like address of your seller, stuff like that. When I say address, I mean address of your wallet where you have or not have enough resources for that. So all of that is happening, and when you call that function, that's going to create a transaction, and you're going to add that to the chain and say, cool, somebody bought a house. And right now, we can't change that because that's happened in the past. Miner approved it, and we can't resell that house over and over again. Okay? So basically, that's how it works. Do you have any questions before we go to use cases? Okay. So, NFTs. Have you heard about NFTs? Okay. So, I hate NFTs. Just to say, like, I don't see the point in them at all. But I wanted just to explain, like, to give you a perspective and say, don't buy NFTs. Don't. So you have a simple picture. I just copied, like, hey, this is my NFT. Like, I paid $0 for this, like in my presentation. So what's happening? People are buying just to say their name is owner of this image. But I have this image, like, who cares? So you know that you have these transactions. This image can be added as a transaction. Miner will approve it and add it to the chain. That's the whole story. But where is this image? So is it really in the chain? Is it in a transaction? Unfortunately not. So what's happening, there is something called IPFS. You don't have to remember that at all. People will basically store that image there, like a database, paste that image, like drag and drop. That's it, like really user-friendly how it looks like. That will generate URL, HTTP, / www image, whatever name, and that's it. And that URL will be stored to the transaction. And miner will say, that's cool, I approve that. And people will buy that URL. And what it means is somebody who uploaded image can change what is there at the URL. They basically can remove the image. You bought it for thousands of dollars, even millions of dollars right now, and somebody can change what is at the source and say, hey, it doesn't really matter, you know. So that's basically NFTs. That's it. Like URL, a string that's added to the chain, and somebody approves that. That's the NFT. So, yeah.
So does that mean that, I'm sorry, so does that mean that even those most expensive ones
yeah,
don't have any vouch?
So,
Don't have any vouch that's like 300 Ethereum, I
Yeah.
can literally go and delete it.
Yeah. Yeah.
For every NFT on the market, on any.
Yeah. Yeah. That's basically what happens.
That's not.
You have the access to the server, yeah.
Yeah.
Yeah, there is like, have you heard about Solana?
Yes, of course.
So Solana is basically like you have Ethereum, you have Bitcoin, you have a Solana, like the same thing, another cryptocurrency, another chain. In the Solana, you can store actually the whole image in the transaction. So in that sense, it makes more like obviously more sense because you can't change it. And for Solana, if you want to buy NFT, I don't know why would you, but if you want, check if it's on Solana. That's the only concern that I would give you today. But in traditional, like in like Ethereum, for example, you can't store the whole image because of the size. Yeah.
So the only thing that I don't understand, if you don't have access to anything, you do have like
URL.
information, but you don't have access.
Yeah, you need to have accounts.
It's protected in some way because
It is.
their value wouldn't like rise, even though they're
Yeah.
pointless. I completely agree with you.
Yeah.
It's not just like pictures. I know. I mean, I play
Yeah.
with it, but they have some value behind that is not promised. You
Yeah.
get the picture.
Yeah,
That's what you
exactly.
That-
So
that
you
I
get a
understand.
picture, and like if somebody sells you NFT, like a good way would be to sell you also the account access to IPFS. But if they don't do that, like if you just go to, I don't know what is the C, whatever, OpenSea, you go to OpenSea, basically market for NFTs. You can OpenSea.com. You go there and buy NFTs. That's it, like simple website. If they don't sell you the access to the real image, they can change like in a couple of weeks the source. Yeah. Yeah. So there are some value, obviously, but like intrinsic value of technology is not there. Like just perceive the value of you as a user. Do you really want to have your name attached to some piece of information, like such as an image, and say, hey, I'm an owner of this? So it really depends on who you are and what you value. But in my opinion, like having a link that somebody can change is not really valuable $300,000. So I would rather buy a house and add it to the chain as a transaction. So my opinion. You want to ask him?
Well, moral comment. It seems to me that NFTs are like a hammer, so now we're looking for nails to hammer in. I mean, it's probably not useful in this
Yeah.
context, but it needs some pioneers to put money
That's correct.
until we discover what they would be useful for.
I would say that that's the whole Web3 space right now, not only NFTs. Like people will, like I was judging some projects at a hackathon a couple of weeks ago, and people came with absurd ideas. They wanted to transfer everything to Web3. They don't need to transfer everything. Like if it works, like for example, Couchsurf application. Why would you have it in Web3? It works perfectly fine in Web2, and it's user-friendly. In Web3, right now, it's, oh, we are at time. Okay, how many more minutes?
1 minute.
Okay, cool. So, okay, I would just want to close with this. DeFi is basically decentralized banks. That's it. So if you hear about DeFi, decentralized finances, there are some applications that can give you like credit stores and stuff like that using cryptocurrencies. So if you hear that term, I wouldn't suggest you doing that right now because so many of them failed recently. Yeah. Thank you.